Suisse is an iconic representation of Amsterdam's modern residential expansion project. Throughout its history, Amsterdam has continuously undertaken systematic and engineering-driven urban developments to overcome and use its unique geographical features. Especially in the areas of commerce and residential living, many engineering techniques have been applied to support human activities. Shortly after the Atlantic, the newly formed Amsterdam city government immediately embarked on a small but significant first phase of urban expansion. The first expansion primarily focused on the Eastern Harbor District, aiming to increase port and shipbuilding facilities. 3 artificial islands were created by reclaiming the shadow waters beyond the old city's eastern gate, the St. Antonius, and its existing moat. These new areas were developed with shipyards, timber warehouses, and other harbor-related facilities, where Flemish and Jewish immigrants settled along the city's main access routes, forming new upscale residential areas, soon followed by artists. On the west side, in the latter part of the first expansion, the city extended beyond the Singer Canal, which has served as the western defense line, reaching a new outer canal, the Herrenhaar. In the early 17th century, the city revised and expanded the first expansion plan, leading to the second phase of the growth. The second expansion further reinforced both the enlargement of the Eastern Harbor and the Southwest Urban District. In the western outskirts, only parts of the rural area, known as Jordan, were incorporated into the city to minimize costs, maintaining a careful balance between expansion and financial products. By 1613, the basic urban boundaries of the second expansion had been established, laying the groundwork for the far more ambitious third expansion that would soon follow. In response to the continuous population growth and the rise of the upper citizen class in the early 17th century, the city authorities established the third expansion in 1613, an innovative urban plan. This plan was a large-scale expansion covering the entire western sector of Amsterdam, aiming to construct 3 consecutive canals sequentially, encircling the city in a semicircular shape and extending towards the southern area near the Amstel River. In the first phase, among the 3 newly planned major canals, the Herrengracht, initially constructed during the second expansion, was widened beyond its original planned line. Beyond it, the Kaisergracht and the Prinsengracht were dug in succession, systemically and originally connecting from the Brausegracht in the northern west to near the Ladesgracht in the south. The Jordan district was also developed during this period as an industrial area to relocate crowded workshops from the city center to the outskirts, thereby improving the living environment of old urban core. Along the new canals, the city authorities plan to create a high-end residential area in a pastoral setting, deliberately setting high land prices to attract wealthy merchants and administrators to settle in the canal district. Through the third expansion, Amsterdam's urban area expanded dramatically within a short period, and the basic structure of the canal district was completed during this time. In the late 1650s, Amsterdam embarked once again on a major urban expansion. The immediate background to the first expansion was the need to defend the newly developed urban district on the city's eastern outskirts. Throughout the first half of the 17th century, artificial islands created to the east were used for naval shipbuilding facilities and warehouses, and the Dutch East India Company also relocated its main shipyard and warehouses to this area, forming a vast shipbuilding and logistics complex around the eastern docklands. However, these areas remained outside the existing city walls and were vulnerable to attack. Beginning around 1650, the city government started sketching plans which were further developed into a systematic design by the city architect, Daniel Starparrot. The fourth expansion plan aimed to complete the semicircular canal system on the southeast side and to build a new line of fortifications and moats around the outer perimeter for defense. According to the plan, the line of fortifications was extended from the west bank of the Amstel River to the northern Eye Bay, establishing a new eastern defense boundary. Through the first expansion, the iconic horseshoe-shaped canal city, online we recognize today, was established. The expansion of Amsterdam's canals exemplifies the model of a planned city. Unlike the relatively disordered medieval core, the areas newly developed in the 17th century featured a systematically designed grid of streets and panels. The structure of encircling the city with main canals, connected by radial secondary canals and roads laid out along the canal banks, was highly organized and considered both urban aesthetics and logistics efficiency. Another notable feature was the spatial division of the city according to use and function. Workshops and warehouses were concentrated in industrial areas like the Rodan district, while the Canal district were reserved for high-end residential neighborhoods with a unified landscape. The reclaimed harbor islands were designed for industrial functions such as factories and warehouses, separated from the residential areas of the city. This functional differentiation of urban space was a pioneering concept for its time, making Amsterdam a model of 17th century European urban planning. The urban development of 17th century Amsterdam, marked by remarkable engineering innovations in land reclamation for harbor construction and canal building for transportation infrastructure, was an innovative city where civil engineering and logistics infrastructure were seamlessly integrated into urban design. Civil engineering was crucial in building a best city on the soft ground of the Netherlands. During the 17th century expansions, the first and most important task was large-scale land reclamation. Throughout the expansion projects, tens of thousands and tons of sand were continuously transported, and sand excavated from canals construction was reused to elevate low-lying areas and create artificial islands. More than 100 bridges crossing the canals were newly built during the 17th century expansions alone, establishing an urban infrastructure where the network of waterways and roads were originally connected. Human and horsepower were the primary sources of energy for canal construction, and excavated soil was reused to raise and sterilize the low banks along the canals. The Netherlands has a traditional method similar to the cofferdam technique used for underwater construction. To allow dry construction in specific canal sections or foundation works, double sheet pile walls were created, filled with clay or mud between them, and water was pumped up manually or using windmill-powered water wells. The weakness of the ground base was compensated by timber pile foundation methods. Buildings constructed in 17th century Amsterdam were erected on dozens of sturdy oak piles. Mechanical pile drivers have been used in the Netherlands since the late 14th century. A heavy weight was installed on a high wooden frame structure lifted by ropes and dropped onto the pile to drive into the ground. Pulleys were used to lift the weight, and after each drop, the pile was driven a few centimeters deeper, with vertical alignment continuously checked during the process. Once all the piles were installed, they were leveled, and wooden logs or stone beams were placed across them to distribute the load, forming a solid foundation. The piles were always kept below the groundwater level to prevent decay from air exposure. In Amsterdam, a city interwoven with canals, water management was a matter of survival. Located at the convergence of the sea, rivers, and lakes, the city faced the critical challenge of preventing floods and maintaining stable canal water levels. Amsterdam installed sluices and weirs throughout the city to manage the water levels and flow rates of each canals. The basic principle was to maintaining the canal water level nearly equal to the average sea level of the I-Bay. By doing so, sluices connecting the harbor and the city's canals could generally remain open without causing significant differences in water levels, ensuring smooth navigation for ships. The gates were only closed during times of large tidal fluctuations to regulate the flow. The sluices used in 17th century Amsterdam were primarily wooden gates. The sluice frame were constructed with thick oak timber anchored on pile foundations to withstand the flow of canals and rivers. The gates themselves were composed of thick timber planks, either layered or reinforced with locking mechanisms, and operated in a vertical sliding manner. In the 19th century, riding the wave of the Industrial Revolution and transportation innovations, Amsterdam built critical infrastructure for modern urban growth, including the opening of the Northern Sea Canal and the construction of the railway and central station. In the early 20th century, Amsterdam accelerated its efforts in housing reform and modern urban redevelopment. Unlike the city expansion driven by the imperialistic spirit of the 17th century, the urban elite, influenced by socialist tendencies and Le Corbusier's modernism, turned their attention to the new issue of improving housing conditions for the working class. With the enactment of the Housing Act in 1901, planned urban reforms such as Plan Jude were implemented. These new developments featured wide streets, spacious squares, and abundant parks, organized into large residential blocks composed of apartment buildings to create a pleasant and modern living environment. As citywide integrated planning progressed, apartment buildings were unified under the Amsterdam school style, an expressionist architectural style characterized by smooth, flowing forms that symbolized the spread of beauty to the working class. When constructing a modern city in Amsterdam, the process of canals, soft ground, and narrow alleys made the installation and maintenance of urban infrastructure such as piping, electricity, and telecommunications highly complex. In the early 20th century, underground utility corridors were introduced as a solution to the complicated infrastructure issues intertwined with the canals. These underground channels, designed beneath major roads and squares, housed all public utility pipelines together, improving accessibility and facilitating easier maintenance. Due to the soft ground, Amsterdam's urban infrastructure was built on piles. Because pipe and cables were highly susceptible to settlement, they were installed shallowly, and when crossing under canals, they were laid on trays or structures supported by piles. For pipelines, joints were designed to allow slight reformation to prevent brutal fractures. Similarly, for electrical and telecommunications facilities, dedicated conduits were installed beneath penetration walkways around the canals, and horizontal directional drilling technology was used to bore horizontally beneath the canals. Iberg is the most modern of the urban residential projects that Amsterdam has continuously pursued. Just as each project throughout the city's history reflected its background and thematic concerns, the Iberg project embodies the contemporary themes from Amsterdam's society. Aimed at addressing housing shortages and the redevelopment of the Eastern Harbor, Iberg carries the theme of environmental and social sustainability. Centered on the concept of harmony with water, the project was developed as a waterfront city, creating canals and artificial islands that emphasize coexistence with water. This approach aligns with Amsterdam's urban policy goals, which promote a compact city strategy, environmentally friendly waterfront development, and social integration. Iberg features a structure where multiple artificial islands, each embodying different ideas of harmony with water, are connected as an archipelago. Harpening Land is the mainland of Iberg, designed with a focus on mid to high-rise apartment blocks to accommodate a high population density. Steger Land emphasized waterfront living, featuring a variety of individually developed projects such as unique single-family homes, villas, and floating houses. Aalborg is a waterfront city developed using a spring-thin layers technique, going beyond the traditional polder method of building dikes and filling the interior with soil. This method involves gradually forming ground by spraying thin layers of sand onto the lake bed, showcasing the advanced level of land reclamation technology that Amsterdam has developed over centuries. This project adopted an approach of embracing water rather than excluding it, a core principle to prevent IMEA Lake's water quality deterioration from land use. An independent internal canal system was designed within the island to manage rainwater and canal water separately. Aalborg's internal canals are connected to the external lake through sluices, allowing the water level within the island to be controlled within a 60 cm range to maintain flow safety and stability. The Aalborg project introduced a unique residential model of floating houses. These houses are built on floating concrete foundations and are secured to nearby paths using rails or mooring poles, allowing them to gently rise and fall with changes in water level. The floating houses are constructed using concrete casing structures, sealed concrete boxes that generate buoyancy like a ship, and serve as a foundation of the building. These caissons are manufactured as single units in shipyards to ensure durability and are transported to the site via waterways. During the design process, careful attention was paid to ensuring stability. Heavier areas such as bathrooms were placed in the lower parts of the structure to lower the center of the gravity, and the load distribution for each functional area was precisely estimated to achieve balance. Additionally, to enhance stability, multiple houses were connected into unified clusters, increasing the horizontal surface area. Instead of roads, jetties serve as the village's streets, with walkways and small plazas installed on the water to connect the floating homes. Aiming for environmentally friendly urban development, the city of Amsterdam commissioned the construction of a thermal energy storage system in 2017. Energy company ATEC drilled aquifers at depths of 100 to 200 meters underground to create thermal storage chambers, establishing a district heating and cooling network that supplies energy to 8,000 households. Using heat exchangers, thermal energy is stored during the summer by capturing the warm surface water from Lake Ymir and used for heating in the winter. Conversely, the cold water temperatures of winter are utilized for cooling in the summer. In addition, solar panels have been installed on residential rooftops, aiming for greater energy self-sufficiency. Solesis is a landmark building symbolizing the Aalborg project, located on Steger Land, with the primary goal of creating a waterfront environment. Just as various engineering techniques were employed throughout history to meet the needs of different eras, modern technologies have also been applied in Solesis. Sharing the core values of the Aalborg project, Solesis incorporates various initiatives aimed at harmony with water and sustainability. Among these initiatives, we plan to begin next week by focusing on Solesis MEP related to environmental sustainability.